Now we will do permutation related questions for numbers and words. Starting out with numbers. This is a little different from what we have done in permutation earlier because numbers inherently allow for repetition. They don't need to mention that. Say for example you have 6 digits and you have to put them in 4 places, which means you have to form a 4-digit number using these 6 digits. The difference in this case is, say digit 1. Digit 1 can occur in the first place as well as in the last place. Right? It is allowed. If there is a number which starts with 1 and ends with 1, it is not a wrong number, it is acceptable number. Say like 11, 111, 1111, all these are acceptable numbers. But you can't put a human being both in the first place and the last place. That is impossible. Until unless of course there is Rajnikant, then anything can happen. But as far as numbers and digits are concerned, even if they are normal average numbers, middle class numbers, still they have the flexibility to occur in multiple places, which will change our answer compared to what we used to do earlier. For example, there are 6 digits, there are 4 places. Let's take an approach that we learned in the very first session. How many of these 6 digits are eligible to come in the first place? Obviously all 6 of them, any 6 can come, any one of them. Now, after one of them has been placed here, how many are eligible to come in the second place? Now this is the critical part. Normally the answer would be 5, what we have learned and all. But in this case, the answer would be, how many of them are eligible to come in the second place? It would still be 6, not 5. And why is that so? Because the digit which has come in the first place can again come in the second place. How many of them are eligible to come in the third place? 6. Fourth place? 6. Therefore the answer is 6 to the power 4. How many 4-digit numbers can you form from these 6 digits? 6 to the power 4. Alright, we understand this? Okay. Extending this logic, how many 4-digit even numbers can I form? Same kind of idea. First place 6 possibilities, second place 6 possibilities, third place 6 possibilities, but even number means the last place has to be filled by an even digit. How many even digits do we have here? 2, 4 and 6. There are 3 even digits, which means there are only 3 possibilities for the last place. So the answer is 6 cube into 3. How many numbers divisible by 5? I am sure by now you have totally understood what we are supposed to do. 6 into 6 into 6. Numbers divisible by 5. Last place can only be filled by 5. So 6 cube, right? 6 cube. Now 5 means there is only one possibility. The numbers that we are writing in the blank is not the digit which will come in the blank, right? It is the number of possibilities. Which of the digits are eligible to come in the blank? So in the last place there is only one possibility, 5. So the answer will be 6 cube. Now say the question is, how many 4-digit numbers which are divisible by 4? 4-digit numbers divisible by 4. Divisibility rule of 4 is the last 2 digits should be divisible by 4. Okay. Now last 2 digit, for last 2 digit to be divisible by 4, how many choices do we have? Obviously there is no 0, so we cannot have 0, 0 or 0, 4 or 0, 8. So we'll start with 1, so it can be 12, it can be 16, it can't be 20, but it can be 24. No 8, so no 28, but 32 obviously, 36 would be there, 42, 40 is not allowed, but 44 can be there, repetition allowed, 48 is not possible, so straight away go to 50 now, 52, 56 can be there, 60 not allowed, but we can have 64. Now henceforth no other multiple of 4 can occur in the last 2 places, which means how many choices for the last 2 places? 1, 2, 3, 4, 5, 6, 7, 8, 9. So last 2 places can be filled in 9 ways. All of them are multiples of 4. But remember, whichever digit, whichever option we select here will involve 2 digits. The 2 digits which have been used in the last 2 places can again repeat in the first 2 places. So for the first 2 places, the number of possibilities remain what it is, which is 6 into 6 into 6. 36 into 9, which is equal to 324. Okay. Right? Okay. If repetition is not allowed, in that case, the approach would be identical to what we have been doing with people and chairs. Same kind of approach. So I'm not discussing it here. I'll just take one example and we will discuss it. For example, if you have to find how many 4-digit numbers can I form with these digits 1, 2, 3, 4, 5, 6 which are divisible by 2. So in the first place, so first let's take care of the last place where only even number can go, even digit can go. So here you can either have 2 or 4 or 6. So there are only 3 possibilities. But whichever of these 3 digits I put here, because repetition is not allowed now, one of these 3 digits which will go here cannot be used anymore now. It is out of use now. So out of 6 digits, one of them has been used. One even digit has been used, which I cannot use anymore. So I have only 5 digits left. So in the first place there are 5 choices. Therefore in the second place there are 4 choices. In the third place there are 3 choices. And in the fourth place also there will be 3 choices. Because fourth place has to be an even number, which can be filled in 3 ways, 2, 4 or 6. So answer for this particular question would be 20 into 3, 60 into 3, 180. 4 digit even numbers to be formed from these 6 digits, right? So one example, if repetition is allowed, alright? Now all the cases we have taken till now of numbers and all, how to form numbers, repetition or no repetition, there was no zero. Now here zero will play a very critical role. So let's take a few examples with zero. First we will do what we have been doing, that is repetition allowed. So let's take these 6 digits. Now let's form a 4-digit number. How many 4-digit numbers can I form with these 6 digits? First place cannot be 0, so 5 choices. Second place, any of the 6 digits. Third also any of the 6 digits. Fourth also any of the 6 digits. So 216 into 5, 1080. How many even numbers can I have? First place 5 choices. Second place 6, third place 6. Fourth place has to be an even number. So how many even numbers do I have? 0, 2 and 4. So 3 choices. So 36 into 15, 540. How many numbers divisible, 4-digit numbers divisible by 5 can I form using these digits? First place 5 choices, second place 6 choices, third place 6 choices, and in the last place you can have 0 or 5. So 2 choices. So 36 into 10, 360. Now comes the tricky question. How many 4-digit numbers divisible by 4 can I form using these digits? Alright. Now 4, obviously the rule is the last 2 digits should be divisible by 4. It's tricky because 0 is also in there. So let's see what approach can I take. Remember, last 2 digit must be divisible by 4. Now, what are the possible choices of making my last 2 digit divisible by 4? With these digits, 0, 1, 2, 3, 4, 5. 0, 0, 0, 4, 1, 2, 12, 16 not possible because there is no 6. 20, yes. 24, yes. Then 32, 36 not possible because there is no 6. 40, yes. 44, yes. 52, yes. 56, not possible. Henceforth, 56 onwards, no multiple of 4 can come here because we don't have 6, 7, 8, 9. So we have 8 possibilities for the last 2 places. But the first 2 places can be filled by these 6 digits, but 0 cannot come in the first place, so 5 choices. Any of the remaining 6 can come in the, including 0 can come in the second place. So 8 into 30, 240 will be my answer. Alright? Okay, so we understand. Now one thing you must have realized here is that all the questions we did with repetition and all, so repetition questions are actually easy because the constraints are less. You don't have to worry about which number has already been used and therefore cannot be used again and all. So when you have a free hand, things become a lot easy. It's only when you have conditions, constraints, limitations, then you have to think a lot more. You have to remember what you have done earlier, what has been used, cannot be used anymore, and then becomes a little more challenging. Let's take one question and try to solve that. Say for example, you have digits 0, 1, 2, 3, 4 and 5. You have to form a 4-digit number divisible by 4 without repetition. Remember, this is now without repetition. So divisible by 4 without repetition. Okay. Again, obviously the approach is same. We try to identify cases for the last 2 places. such that last two places divisible by 4. Now the only difference here is that in a case where 0 is being used in the last two places, for example a case like 0, 4, I know 0 has been used in the one of the last two places, which means 0 cannot come in the first place anymore, right? We understand this? 0 has already been used, so 0 is, once used, it's useless. So it cannot come in the first place. Any which ways it cannot come in the first place, but I don't need to worry about it coming in the first place now. There is no transgression, there is no gate crashing by 0 coming in the first place. 0 is very keen to come in the first place. We have to stop it at any cost. How do I do that here? I put it in the third place, 0, 4. So I achieve twin objectives. My number is divisible by 4, whatever be the first two digits. Also, 0 already used, it cannot come in use anymore. So I don't need to worry about it. But what if I take a case like this, 12? Right? Now 12, I am not using 0, I am using non-zero digits, 1, 2. But 12 is also divisible by 4. So that helps me attain my objective. But you still must be aware of the fact that 0 is out there in the open. Something to be apprehensive about, to be worried about. 0 can find a way to come in the first place now, and we have to be very wary of that, right? So the number of ways in which I can fill my first two places when I take 0, 4 in the last two places is different from the number of ways in which I can fill my first two places if I take 12 as my last two places, right? So I cannot club all the cases together, because in different cases the number of arrangements will be different. So I have to break all my cases into two groups. Cases where 0 is being used in one of the last two places, cases where 0 is not being used in one of the last two places. Let's take all the cases, we'll understand this better now. So as we discussed, let's take cases where 0 is occurring in the last two places and the last two places divisible by 4. Okay. Remember, there is no repetition, so I cannot take a case like 0, 0. Okay. So I can take 0, 4, 0, 8, not possible because there is no 8. So in less than 10 only one number is possible, 0, 4. No other number less than 10 is divisible by 4. How about numbers more than 10? So yes, 20 is possible, 40 is possible. Is 60 possible? There is no 6, so 60 is not possible, and therefore 80 and onwards is also not possible. So how many cases do I have? 3. Now understand this, in each of the 3 cases, I am using up 2 digits out of 6. There are 6 digits, 0 to 5. I am using up 2 digits, whichever case I take. One of the 2 digits is 0. So I originally had 6 digits, I have used up 2, so I am left with 4 digits. And remember, there are all 4 non-zero digits. There are 4 non-zero eligible bachelors for me to put them in 2 seats right on the front of the dais. How do I do that now? No constraint. So random selection, which means any of the remaining 4 can come in the first place. And once one person is seated out of 4, 3 are standing. So any of the remaining 3 can come in the second place. So in how many ways can I have a 4-digit number divisible by 4? Where 0 is one of the last 2 digits. 4 into 3 into 3, 36. Now let's take cases where I don't use 0 in the one of the last 2 places. So I'm taking a bit of risk here. 0 is out there in the open, but I keep that in mind. So I'll ensure 0 does not come in the first place. So how many cases to fill the last 2 places divisible by 4 without 0? 12, 24, 32, 36 not possible. 44 also not possible because without repetition. 48 not possible, no 8. 52, I think we are done now, right? So how many cases have been able to identify? 4 cases are there. Any of the case that I take, say 12 or 24, I'll use up 2 digits out of 6. I had 6 eligible bachelors, I've used up 2. So I'm left with 4. But out of those 4 bachelors, one of them is a rogue one. I can't stand him at all. You know, I have to include him if I must, but I'm definitely not going to give him in the first position. So out of 6, I have used up 2. So 4 of them are there. I will take any of the remaining 3 non-zero to become my captain, my first place player. 3. That headache is also over now. So I got a good eligible captain. My last 2 digits are divisible by 4. Only 1 place left. Let's again revise the whole thing so we don't commit a mistake. There were 6 gentlemen. I have taken 3 out of 6. I still need 1 more. Now there is no constraint. Second place is a very safe place. You can take anyone, no problem at all. So I have used up 3 out of 6. So 3 are still there out in the open waiting for their turn. I can take any one of them. So in how many ways can I have a 4-digit number divisible by 4 where 0 is not one of the last two digits, 3 into 3 into 4, which is equal to 36. So total number of cases 72, and there we have our answer. Nothing gives you more satisfaction than getting an answer in maths. It's weird, but that is how we have our fun. We can't help it. We are the nerds of the world. Right? So we understand this, great. So we understood repetition and non-repetition, everything. Now extension of this is words. There is no difference. What you have to understand here is, in numbers, there are 10 digits, 0 to 9. Everything revolves around them. And repetition is allowed. You can have 1, 1, 1, 2, 4, 3, 2, 4, 6, 6, 8, 6, whatever. All these are numbers, acceptable. Unless and until question specifically says no repetition. Isn't the same true for words, alphabets? Instead of 10 digits, you have 26 alphabets in English language. Right? It's A to Z. Okay? Yes, there are some specifications there. 5 vowels, 21 consonants and all. For those of you, I won't say don't know, because that would be a little insulting to you, are not able to recall the exact meaning of consonants and vowels. Okay? Just a quick revision for them. A to Z, 26 alphabets, out of which A, E, I, O, U are vowels, and rest are called consonants. Okay? Consonants. Great. When we did that way back in our kindergarten, we never thought that this is actually going to help us in our CAT somewhere down the level. I'm sure even our kindergarten teacher was not aware of that. But see, life turns a full circle. So there are 26 alphabets. Now what you have to understand here is that when we form words in math or permutation, we are not talking about dictionary words, meaningful words, words that convey meaning, some sense. No. Words in math means string of alphabets, some arrangement of letters. That is what words mean. So A in mathematical language, in this weird word, is actually a word. Alright? So we don't look for meaning, we just look for arrangement of letters. Alright? Now once we do that, then life becomes so much more simpler, which is what our objective is. How do I form a 3-letter word? A simple question. How many 3-letter words can you have in this word? You can have 26 letters in the first position.